This question is asking us to evaluate the definite integral of this given function right here on the interval from 4 to 7. Now we can easily do this with Excel. What I did here is I put in from input values from 1 to 10, although we could have just done from 4 to 7. And then I put the given function that's given here, which, remember, any function that sits next to an integration symbol is a derivative function. So I labeled that as a derivative. Our goal using the fundamental theorem of calculus is to find the antiderivative of this function, and then evaluate it at the bounds from 4 to 7. Here I graphed what this antiderivative function looked like, and remember what this means. It would give me the area under the curve from 4 to 7, which would give me the amount of accumulated change in this antiderivative function over in the given interval. First, let's find the antiderivative of this function. So to find our antiderivative of this function, remember we use our antiderivative rules, excuse me, and our antiderivative function becomes 2x to the third minus 5x squared plus 4x plus c. Again, using our rules for antiderivatives, where we add 1 to the exponent and divide by that same exponent, and then I just reduce this 6 divided by 3, 10 divided by 2. And remembering that when we use the fundamental theorem of calculus, we're going to subtract. So with the c's, we'll subtract each other, so we don't actually need to put them in our problem when we use the fundamental theorem of calculus. And that is that the definite integral from 4 to 7 of this given function is going to be the antiderivative evaluated at the upper bound of 7 minus the antiderivative at the lower bound of 4. Now you could do these by hand, but because we have Excel, it's so much easier to do it in Excel. We would put the antiderivative into Excel as our next column, so our antiderivative is put there. And then it's really simple to find using the fundamental theorem of calculus. We just say this is going to equal to the antiderivative at 7 minus the antiderivative at 4. So in this case, the definite integral, or the amount of accumulated change of this function over this given interval, is 405 units.